The broadcast is now starting. All attendees are in listen-only mode.
Hey guys, welcome to the webinar for the PTP 550 update. My name is Sagar Deshpande. Let's wait maybe for a minute or so for more people to gather up. Also, feel free to ask questions along the way. I'll be taking questions towards the end and trying to answer them as quickly as I can. Okay, I think we can get started. This webinar will also be available online for you guys to review later on. Hey guys, welcome to the Cambium webinar once again. So today I'll be going over the PTP 550, which is part of our point-to-point portfolio. And on this screen slide, you can see our current product portfolio for point-to-point solutions. Way on the left-hand side, we have the Force 200, which is bridge in a box solution, which is based out of 802.11n, followed by the Force 300-25, which is based out of 802.11ac Wave 2. Then we have the PTP 450, which is based on the 450 proprietary platform, and which is an upgraded 450i, followed by the new PTP 550, and then towards the end we have the PTP 670. I'll kind of go spend maybe a minute or so on each of the products and where it kind of fits in and a couple of its highlight features. So bridge in a box is a DIY kind of a solution. So it's used for extending network to a local new location. It's typically from 1 to 2 miles, but it's more like a garage project. So if you want to install something on like a garage side and then shoot it across the room or probably shoot it across the street, you probably want to use a Force 200, which is already pre-configured. The Force 300 has a range of around 40 miles, and it has a max throughput around 600 Mbps, and it can support the 20, 40, 80 megahertz channel sizes. The PTP 450 main is based on a 450 platform. It syncs with the PMP 450. It also has narrow channel sizes, which is really good, and its top throughput is around 200 Mbps. The next is PTP 450i. This has a couple of advantages. So one, again, it syncs with the PMP 450. It has a dynamic filtering, so it kind of reduces interference from co-channel interference. Also, it has the aux port, so if you want to set up like cameras or Wi-Fi hotspots, it's much easier. Also, this supports narrow channel sizes. So you can do like a 5, 10, or a 15 megahertz channel if you get a congested network, and at peak throughput is around 300 Mbps. Next, we have the PTP 550. Some of its key highlights are 1.4 gigabits per second, asymmetric channel aggregation, DCS, which we'll get into a little bit, and live spectrum analyzer that we have. And on the right side, we have the PTP 670, which is a flagship product, which can do a point to multi-point capability, which we call as high capacity multi-point. We also have something called DSO, which is dynamic spectrum optimization, which basically means if your current band has some interference, your current channel size has some interference, the PTP 670 can move it to another channel in the same band. The PTP 670 also supports 1588 timer and sync key, followed by non-line of sight and near line of sight solutions as well. So this kind of talks a little bit about more in detail about like the quick summary part of it. So if you want to position the product how it would look, this would be a nice way to represent the throughput versus richness feature. On the rightmost, we have the PTP 670, which has a lot of feature-rich solutions like Syncy, 1588 timer, high capacity multi-point. Whereas on the top, we have the PTP 550, which has a bit of feature richness, less feature richness compared to 670, but it's mainly built for speed. And the PTP 450i has with throughput wise, it's slower than the PTP 550, but it has a different set of feature richnesses compared to the 550 and the 670. And then the 450 we have 450 towards the other end. This would be if you want to plot price versus feature richness. So you have the top right, which is a PTP 670, which has all the features that you would really want in a utility or or in a solution. The PTP 550 is mainly built for speed, and it has a low cost comparative to the 670 and the 450i. All right, let's focus a little bit on the PTP 550 gigabit capacity. So some of its key highlights, it supports the 5.1 to 5.9 megahertz, the gigahertz band. It has 1.4 gigabits per capacity. It has two radios built into it, which we'll get into a little bit more. And each one can be configured as a 20, 40, or 80 megahertz channel. It has asymmetric non-contiguous channel aggregation, which basically means that we have two channels, and they don't have to be of the same size, which is asymmetric, and they don't have to be in the same band. It can be different bands. It has different channel selection modes, so you can use different uplink downlink ratios. Latency one way is about 1 to 3 milliseconds. It has a live spectrum analyzer. It will have the dynamic channel selection, the DCS, which we'll focus in a little bit on. It also has SFP as a fiber port, because a lot of buildings these days have fiber built in, especially enterprise solutions, because they want to provide fiber to the businesses over there. It also has a metal enclosure with the IP66-67 rating. This is the antenna pattern for the PTP 550. It has a 23 dBi gain. This is for the integrated version. The connectorized, you can use any dish or any this antenna that you want. The beam width is around 8 dB, so it gives you ease of use comparatively, and it doesn't makes it easier to align it. The dimensions are, the antenna size is about 12 inches by 12 inches, so it's not that big or bulky to carry around. So PTP 550 covers the 5.1 to 5.9. So what this means is it covers the Uni 1, the Uni 2, the Uni 2 extended, and the Uni 3 bands. And we will also enforce the EN 301, that's the HC requirement, which will be effective from June 1st. But most of FCC, all of FCC is covered in this one. All right. Now coming back to the asymmetric non-contiguous channel aggregation. So basically, the PTP 550 has two radios built into it. We can call it radio A, radio B, or channel radio 1, radio 2. And each of the radio 1 and radio 2 can be can have different channel sizes. So for example, in the table below, you have the channel A, channel B as 20 megahertz. So it's if you're really tough to find two good clean channels, it's a pretty high interference or used up network. So there you can expect a throughput of around 280 Mbps. Let's say you have two channels, one is clean 80 megahertz and the other one is 20 megahertz, then you can expect around 840 megabits per second. So if you have two clean 80 megahertz channel, you can expect around 1.4 gigabits per second. Of course, this depends on how far that you want to point and shoot. All right. So what is the advantage of having two radios built into one? So one of the key advantages you have is something called reliability versus aggressiveness. So so you can have this is a scenario where you can have a reliable 20 megahertz link in channel A and have an aggressive 40 megahertz link in 5.8 band or channel B. So the advantage of having reliable and aggressive is you have redundancy built into the system, right? So if you're sure your 20 megahertz reliable link is going to give you around 150 or 130 megabits per second, you can be confident of, like, even if your channel B gets hit with interference, your link doesn't drop, right? So you might have fluctuations throughout the day, but since you have a channel A which is pretty strong and you can guarantee some throughput along the way, you can be sure you can be a little bit more aggressive on the channel B side of things. So this is one of the advantages. So another advantage for this one would be if you have a DFS band or a non-DFS band. So let's say you have a channel A is present on a DFS band and channel B is a non-DFS band. As you know, DFS is mandated by all FCC products. Basically, it means that if there's a radar, either through military or weather, if you detect anything like that, you have to switch off your radio on that channel for about 30 minutes. So in our case, since we have one DFS and one non-DFS, the DFS port or the DFS radio has to shut down, and then it moves automatically to another band and comes back up. So that feature is called DCS. So the DCS, this dynamic channel selection, it leverages the PTP 550's dual channel design, and it automatically hops in a hit-left fashion, because we have the online spectrum analyzer, which automatically calculates the next best channel in case your link is planning to go down. And the key advantage is this new channel can be anywhere across the 5 gig spectrum. So let's say a new 40 or a 20 megahertz link opens up on a 5.1 band, you can switch over from the DFS to this one and then kind of continue over there. TDD sync, basically this is used to misalign transmit and receive cycle if PTP 550s are close to each other. This is a feature that we are going to have in the near future and release as well. So this mainly, the key advantages of this one is reduce interference from other radios, limits. You can use it when you have less spectrum available, so you can reuse some of the channel stuff. And also it does it generally use it if you have in limited space, you don't have any more room on the tower. The PTP 550 has adaptive modulation, which means if you go from MCS1 to MCS2, there's basically no time lag. So your say your first packet goes at MCS1, the second packet automatically goes at MCS2 if you get less interference, and you keep going until you hit some sort of interference, and then it kind of backs down, and then it finds a sweet spot where you're transmitting more than you're dropping packets, so it makes sense to keep it at that level. We have different uplink downlink symmetric ratios. So right now we support 50-50, 70-30, and 25-75. So these are the throughputs that you expect. Basically, the uplink downlink is divided into a burst duration and duration frame. So by changing the number of time slots, we are able to achieve this one. The PTP 550 has a lot of encryption and protocol built into it. So we support the AES 128 by default for free. We also prevent unauthorized software modified solutions. You cannot load any other image based on that. And each of our software goes through a lot of testing, and we also have multi-level authentication to make sure that your installer doesn't get access to the radio, or you have different admin rights for different applications as well. So the PTP 550 is IP66-67 housing. So what does it do? It helps you protect with solar radiation, hurricane winds, dust and water, as well as harsh weather temperature. The PTP 550 also comes with a mounting bracket. So this is galvanized steel, so it doesn't rust. So it's really good for like if you are near the ocean and if you're expecting like, oh, it's gonna get rusting because of that. But since this is anti-rust proof metal, so you should be good on that side. The PTP 550 also is already supported in link planners. So link planner is our Cambium tool that we use to plan links. It's really easy to use. On the picture on the right side, we have a small simple link deployed. So you have the way you figure out the link A and link B is on the top you have link A, which is your channel A radio, and then the link B is the channel B radio. In this case, we have a link A in the 5.8 band as a 80 megahertz, and then we have a link B in the 5.1 band with the 80 megahertz as well. The PTP 550 is also going to be supported on CN Mastro. This is going to happen relatively soon, within a month. Is what we are expecting. So with this, you will have a unified way of managing your entire network portfolio. We'll also have more updates, which will also have like alarms, some on major, minor, and as well as critical. You can also have like a top-down hierarchical view to kind of see what kind of throughput you're expecting on each one of them. So the PTP 550 has different applications, or it can be used in a variety of ways. One of there's two main reasons or two main applications where the 550 would outshine other products. Is one, in ideal, PTP 550 is ideally for like mid-range link planning solutions. So it's about 1 mile to about 5 miles. It's ideal for like short backhaul hops, because if you go beyond that, your throughput starts to drop just because of the distance and the free space loss. So it makes sense if you want to get that gigabit capacity kind of a link, you might as well, you have to try to keep it short between 1 to 5 miles. You can extend up to 7 miles, but the radio can be supported up to 100 miles. But to get like the ideal gigabit capacity, you want to shorten it up to about 1 to 5 miles. The other key advantage of the 550, it provides in high noise environment, it provides a backup. So you have since you have two channels or two radios, if one of them gets hit with interference, the other one is not. So there's some sort of redundancy built into the system, so you don't have to always be worried that, oh, is when am I going to get hit with interference on any of the channels. All right, some of the key differentiating features of the PTP 550 is 1.4 gigabits per second throughput, asymmetric non-contiguous channel aggregation. So we can support it in the DFS and non-DFS kind of simulation, or we can have it as an aggressive and resilient network. We have asymmetric modulation between two channels. What this means is, if you have channel A and channel B, if channel A is running, let's say, at 64 QAM because it has it has a medium interference, and channel B is running at QPSK, it makes sense, right? Because you don't want to limit the other radio because you're facing interference over here. So this means that both the radios are completely independent. They work at different modulation rates on their own, so it's not affected by each other. The 550 also has a link redundancy, as I mentioned earlier, that if one link goes down or it has to move because of interference, the DCS automatically kicks in and tries to establish a link somewhere else. The 550 also has a small form factor, and it has some metal enclosure. So it's a really small radio. You can it's much easier to carry it up a tower and kind of maintain it as well. And it's also durable because it has a metal enclosure as part of it. It also has so this one has two ports. One is the fiber port as well as the Ethernet port, or the GigE port. A fiber port can be used for like residential or commercial buildings where they provide fiber connectivity, whereas Ethernet can be a regular Ethernet if you want to shoot up a tower as well. It also supports ARQ. So every PTP 550 comes with it comes in a kit format. I want to talk a little bit about that. Every radio comes with a kit. And in the kit, you have the radio, which could be connectorized or integrated version. You have a mounting bracket, which is rust-proof metal. You would have a AC power brick, which will be used for powering up, and you will have, depends on the SKU, but you probably have a line cord attached to it as well. Line cords are optional for different things. So these are the products that come in the kit. Now I want to talk a little bit about the software that we have and what we want to do about it, and kind of give you a more detailed update on that. So we released the PTP 550 late last month, towards the end, and we also posted a bunch of beta firmware on our web support.cambium.com website. So the beta version that we have supports the 20, 40, and 80 megahertz, and it also supports standard bonding. In the release notes, we do acknowledge there's some still small issues that we have, and we are coming up with beta releases every week, and we are refreshing the website, the web page, to provide the latest beta firmware. We will have an official firmware release by probably end of this month, which will address all of the issues that we have. But if you want to, feel free to try out any of the beta solutions that we have over here. It's free, and then you can kind of download it and see it. All right, with that, I have nothing more to present. I'm going to take a moment to check on the questions if we have any, and then try to answer that. Okay. Okay, so I have a few questions here. The first question is, all right, I see a few questions. Okay, let me see. When will DCS be available? Okay, so DCS is a slightly complicated feature, and we probably want to roll it out in steps. I would say the first prototype would probably be end of Q2, but then we're gonna release it more of it in like phases kind of stuff. So I would say by end of the year for sure we will have a DCS available as part of it as well. Okay. Is the connectorized version 2 RF connectors? Yes, that's right. I think in one of the pictures we do have it. We do have two RF connections. One is for vertical and horizontal. Can we use any SFP? That's a tricky question, because we have our own SFP module, which we recommend, but we cannot guarantee if you use any other SFP and it doesn't work. So we recommend our solutions that we have. And those part numbers and everything should be available from the dealers, or you can ask sales, or you can contact support team to provide those information. Do you guys have any more questions? I'll wait maybe a couple of more minutes to answer any more. If not, just feel free to visit our support.cambiumnetworks.com page and feel free to post a question. Myself and the engineering team will be happy to help out in any question, technical or non-technical questions if you have, especially with respect to link planning, or like if you're facing some sort of interference. We have experts over here who can help out in planning and deploying some links, or maybe seeing why you might be facing a particular type of interference ratio. All right. Okay. I don't see any more questions. Thank you very much for your time. This webinar will be available online soon. You can also go through that. If you have any more questions, feel free to contact communities@cambiumnetwork.com. All right. Thank you so much. Bye.